Hi, we're going to look at factoring the sum and difference of cubes. Difference meaning subtraction. We have a subtraction in the middle, and the numbers on both sides of that minus sign are both perfect cubes. So a number raised to the exponent of 3. So before we do any kind of factoring, I need to break this stuff up a little more. So x to the third, nothing else I can do there but my 64. I can rewrite 64 another way. 64 can be rewritten as 4 to the third power. So we say 4 to the third power, y to the third power, okay? Because they both have an exponent of 3, within our exponent rules, we can kind of put this together and make it say 4y raised to the third power. So now we just kind of simplify this another way. Bring down that minus sign, bring down the x, we have the exponent of 3, and I want to put parentheses around this x just to kind of show that that x is being raised to the exponent of 3, but also I can find what is a, what is b. My a value is going to be this first group. My b value is going to be the second group of parentheses. Now, all we have to do is basically take those numbers and plug them into this bottom formula here. So when I have a number being raised to the third power, x being raised to the third power, minus another number being raised to the third power, or a group of numbers for y, I can just kind of split it all up and just kind of plug things in. So let's do that. When I factor, my first group is going to be a minus b. What's in my a position? Just the x. Minus what's in my b position? Just 4y. Times, here's where things get a little weird, my a value squared. So it's going to be x squared plus my a times my b plus my b value squared. All right, let's kind of put some of it together now. Here we're going to get x squared. In the middle, 4 times this, it's just 4xy. Put everything next to each other. And then on the back side, this exponent kind of gets distributed to everything. So 4 squared is going to be 16. And then y squared. All of this is in parentheses. Bring down what's in front. You just factored the difference of cubes. Okay, what if things aren't as easily seen? So here I have 5x to the fourth minus 320, xy to the third. I only see one perfect cube there. Is that y to the third? Okay, but do those two groups share any numbers? They do. They both share a 5. 5 goes in the first group, 5 goes into the second group. Okay, so if I wanted to factor this, I could pull out a 5. Could I pull out a variable? Well, I have 4 x's here, I have 1 x here. They both share an x. Let's pull that out. And if I were to kind of fill in the rest of this, I would be left with x to the third minus 64 y to the third. How do we know that? Well, 5x times this, add the exponents, 5x to the fourth. 5 times 64 gives you 320. And then you have x times y to the third, giving us here. Okay, so what's so special about this? Nothing really, other than we pulled a 5x out. Now, thankfully, this group is the same thing we just started with, so then we'd have to go through this whole process all over again. The only difference now is we're going to pull out that 5x. We're going to bring down our answer, x minus 4y, x squared, 4xy, 16y squared. And now we have one extra number, or one extra group of numbers out in front that we factored, and that is finding the difference of cubes.